Good morning, class. Today is the section that I was supposed to have posted on Monday, but I put in 8.6 instead. So this is 8.5a, and I wanted to cover the material anyway. It's on adding and subtracting rational expressions. And you'll notice that I stuck this line in here. Think fractions, because we're going to use the same rules that we did when we added and subtracted fractions. And the thing that you have to have, and you know, is that you have to have a common denominator to be able to add and subtract fractions. So if we had 5/3 and we added to it 8/3, this would give us 5 plus 8 or over 3, or 13/3. That would give us our sum there of those two fractions. But if I had 2/3 and I wanted to add 1/5, then I would have to somehow look at these denominators and make them alike. So I'm going to look for the least common denominator, or least common multiple of the denominators, which if you take the prime factors of 3 and 5, both being prime numbers, and multiply them together, 3 times 5 gives me 15, and so my least common denominator would be 15. What do I have to multiply by 3 to get 15? That would be 5, so we'll take our 2/3 and multiply it by 5, but I can't just introduce a 5 in the denominator. I have to introduce it by multiplying by 1. So we'll make it a 5/5 and multiply those guys together. And then I will do the same thing with the 1/5, using now what times 5 would give me 15, and that would be 3, and then I have to do a 3 in the numerator as well. So this is going to give us, if we multiply these two together, that would give me a 10/15 plus, and if I multiply these together, would give me a 3/15, which gives me a total of 13/15. And that's how I would get the sum of those two fractions. I'm going to use that same idea as I'm dealing with rational expressions. Let's look at what it looks like to get common multiples as we approach common denominators with variables. Okay, so I have in this first expression 12x squared y times a trinomial. And I'm going to have to factor that trinomial. Okay, so we will have to take this trinomial in its factored form, plus we're going to want to factor each of these terms as well. Then we're going to factor these terms as well. We'll factor that trinomial, 18, and y to the third. And so here's what's going to happen. With 12x squared y times x squared plus 2x plus 1, you would factor x squared plus 2x plus 1 and split the x's. Factors of 1 that give me a sum of 2, it would be plus 1 plus 1. So you'd have x plus 1 times x plus 1, or, as they showed here, x plus 1 squared. Right? The number 12 has a couple of factors in it. If you took it down to its prime factorization, using a factor tree or whatever method, it would be 2 times 2 times 3, and they have shown that right here. 2 times 2 would be 2 squared times 3, and then the x squared and the y they just left alone. For the 18xy cubed, we did the same thing. We factored this x squared plus 5x plus 4 by splitting the x's, and then factors of 4 to get a sum of 5 would be plus 4 plus 1. Okay, and that's what we have with this expression. It's written out there. And then 18, which would be 9 times 2, or 3 times 3 times 2. So in this one, we're going to have 2 times 3 squared times, and then the x and the y cubed they left alone. Now, if we started looking at what's in common, let me get a little bit bigger of a pencil here and cross and scratch. To get what's in common, it is the product of the common factors plus the non-common factors. Okay, so if we took our common factors, there is a 2 in common right here and here. There's one common factor of 2. Let me show it this way. Common and non-common. Okay, common and non-common. You would have a 2 that's common and a 2 that's not common because the top one had an extra 2. There's a 3 in common, but there's another 3 in the bottom one. That's not in common, so you have 3. All right? And then you have a y in common and an x in common. But there's another x on top, and there's 2 more y's or y squared on the bottom. Now there's a binomial term of x plus 1, and then there's another x plus 1 on the top that's not common, and there's an x plus 4 on the bottom that's not common. So if we multiplied and got the common times the non-common, this is what it would look like. But we can reduce all that. So let's go ahead and reduce that. I'm going to get a smaller pencil here. And if we reduce that, this would be 2 times 2, or 2 squared. Okay, 3 times 3, or 3 squared. Y times, or x times x, which would be x squared. And y times y squared, or y cubed. All right, there's my terms, and if you'll notice, that's the numbers or the monomials right here that I just circled. And then with this x plus 1 times x plus 1, we're going to get times x plus 1 squared, which is that term, the binomial squared. And then the final is the x plus 4. And that gives us then the product of these 4 monomials, 2 squared, 3 squared, x squared, y cubed, times x plus 1 squared times y, or x plus 4. This whole expression then matches this expression. So that becomes our least common multiple. If you factored all those out, those number parts, 2 squared times 3 squared, that's 4 times 9, which is 36 right there. And then your x squared, y cubed, x plus 1 squared, and x plus 4. We will do that with our next slide. Our next slide is find the least common multiple of 2x plus 4. Well, if you take 2x plus 4 and factored it out, you can take a 2 out, and an x plus 2 is left over. And then you have your x squared minus x minus 6. And if you factor that down, that would give me the eyeglasses, split the x's, factors of 6, negative 6 rather. That gives me a sum of negative 1. That would be minus 3 plus 2. Okay, so if I used my common times my non-common idea, what I have in common is x plus 2. All right, so we'll put down x plus 2, a binomial. And now those guys are covered. And then what's left over? Well, there's a 2, that's non-common, and there's an x minus 3. That's non-common. The product then of all of these would be 2 times x plus 2 times x minus 3. And if you noticed up above in the example they gave, they left it in the factored form, and we will too. All right, now why would we do that? Let's take a look at this problem. Adding 2 rational expressions. All right, I'm going to get a black pen here, pencil, and I have x plus 1 in its already factored form because it can't be broken down. However, x squared, this factor, or this denominator, can be factored. If I get my eyeglasses, split the x's, we can get factors of 2, sum of negative 3, minus 2, minus 1. Now, if we used this term, and I'm going to go to a different color here, I'll go to orange. If we took this term and its factored form, disregard the trinomial right now, we're going to work with the factored form. So, x minus 1 and x minus 1, x minus 2, I chose to write those minus 1s on top of each other. The common factor would be x minus 1. The non-common would be what's left over. Well, that's taken care of, so x minus 2. So our least common denominator in this case, LCD, would be the product of x minus 1, x minus 2. All right, so here's what we're going to do. Any restrictions on this in the denominator? Yeah, if you had x minus 1 in the denominator, you can't have x equals 1 because 1 minus 1 would be 0, and we can't have a denominator in the of 0. That's dividing by 0, which is undefined. And x cannot equal 2, because if you had the x minus 2 up here in the denominator, then you could not have a 2. So x cannot either equal 1 or 2. But x can be all other real numbers. So we'll just say it this way. X cannot be 1 or 2. And that implies then x can be anything else. All right. Our last one is, okay, what's the sum then of x plus 1? Oh, I forgot to add these guys together. So, here's one way of doing this. I could try to get those denominators equal to each other by multiplying this denominator up here, let's go to a green, by multiplying by x minus 2 on the downstairs, but that means that I got to multiply it by x minus 2 on the upstairs. Okay, now I'm going to have to erase some stuff down here so I have some room to write. Okay, and if I did this, now I have a common denominator in both x minus 2, x minus 1 in both of these terms. So this would be, it would leave me with an x times x minus 2 for the first term, plus, and then on the second one I've got 2 times x, yeah, back that up, I got the parenthesis in the wrong place there, 2 times x minus 1. I don't need a parenthesis. Alright? And that's all over the same denominator. So right now I'm just going to put my least common denominator. And that's going to give me, then I'm going to have to distribute this, which would give me an x squared. Minus 2x. Now that is going to get added to 2x minus 1. So if we take my negative 2x here and add it to my positive 2x here, those guys are going to cancel each other out. So that's going to give me an x squared minus 1 over x minus 1, x minus 2. Okay. So we now then take our numerator and say x squared minus 1. Hey, that's the difference of two perfect squares. So I'm going to get this smaller again. Difference of two perfect squares would be x plus 1, x minus 1 over the denominator as x minus 1, x minus 2. Now, if we take the x minus 1s and cancel them out, okay, by the way, remembering that x cannot equal 1 or 2, okay, that's my restrictions. Okay, that was the restrictions here. So I'm going to be left then with, in simplified form, an x plus 1 on the top and an x minus 2 in the denominator. There is my simplified form. That's the sum, simplest form. And here are my restrictions over here. Okay? And that's what we're going to do with this problem. So let's look at the next one, which, by the way, is